So we are simplifying rational expressions today. You guys are going to be able to take rational expressions and basically cancel out common factors, really and truly. So what are rational expressions? A rational expression is an expression that can be written as a ratio of two polynomials. A ratio, another word for that is a fraction. So basically you're going to be dealing with fractions, functions that are fractions, and you're going to have a polynomial on the top and a polynomial on the bottom. An excluded value is a number that makes a rational expression undefined. Since we're dealing with a fraction, what number cannot be in the denominator? 0. So an excluded value is whatever's going to make the denominator 0. And a rational expression is in simplest form when the numerator and the denominator have no factors in common other than 1. Hence why we spent that time, that first little bit, reviewing factoring. Okay? You're going to need to know how to factor in order to simplify these rational expressions. All right? So let's start at the very basic. Let's make sure that we remember how to find excluded values. Now, we did this in the last unit when we were doing interval notation. Okay? And remember, what number cannot be in the denominator? 0. So we set the denominator equal to 0 to figure out what that excluded value is. How do I solve here? Divide by 6, because that's 6 times x, so we divide by 6, and x equals 0. So 0 is my excluded value. That means that every number except 0 is going to work for this function, or this expression. So how do I write that in interval notation? Who remembers? How do I write every number except 0? With a very good. That's how we write. So if I ask you what's the domain of this rational expression, you would be able to tell me this is wherever the denominator equals 0. I do the same thing here. I have 3x plus 12. So I said 3x plus 12 equal to 0. How would I solve this? 5. And then, so x is going to be, so every other number except -4 works for this expression. So you'll write the same way, except instead of a 0, you would have a -4. So negative infinity to -4, union -4 to infinity with parentheses around everything. Remember, the parentheses means what? It's not defined there, which makes sense because -4 would give me 0 in the denominator. All right? What about number 3? If I set number 3 equal to 0, how do I solve this? I add 4, and then take the square root. Now, who remembers? When we take the square root in an equation like this, what's the answer?
It would just be square root 4.
What's the square root of 4? So is it positive 2? Plus or minus 2. It's plus or minus 2. Okay? Another way you could look at this, if I set this equal to 0, this is a quadratic. Can I factor x squared minus 4? We actually can. You missed this. How? We just talked about it. X minus 2, x plus 2. This is a difference of perfect squares. There's a minus. X squared is a perfect square. 4 is a perfect square. So I could have factored this and then set each factor equal to 0. So x minus 2 equals 0. X plus 2 equal to 0. So that's where the positive and the -2 come from. Okay? Quick review of last unit. How would I write this in interval notation? Negative infinity to -2. I'm missing something. -2 to +2. You can't forget about the numbers that are in between -2 and +2. Okay? So -2, +2, open circle at both, and everything else. Okay? Now, will I ask you to do this? I'm just adding in some additional practice because later we are going to have to find the domain for these functions, okay? So this is good practice. But if I just ask for the excluded value, x equals 0, x equals -4, x equals ±2, that's all you need, okay? This last one, when I set this equal to 0, I have a feeling somebody's going to tell me to add 10. I need to factor this. I cannot add 10 here. I have a whole quadratic, an A, a B, and a C. Okay? How would I factor this? Very good. -10 on top, -3 on the bottom. What are my two numbers? Okay. -5, +2. So this turns into an x minus 5. X plus 2 equals 0. So I have to set both factors equal to 0. So x minus 5 equals 0. X plus 2 equals 0. What are my two excluded values? 5 and -2. And that's how you find your excluded values. You just set them equal to 0. Questions? So to find your excluded value, what do? What is it? Set the denominator equal to 0. Let's divide this. We are going to simplify this rational expression if possible. Sometimes you might not be able to simplify. Then we're going to state the excluded values. Now, when you do this, anytime I ask you to state the excluded values, you need to do that first. Always state the excluded values first if it asks you to do this. So we're going to do this first, and then we're going to simplify. Okay? How do I find the excluded values? What do? I said 3x equal to 0. When I solve this, x equals what? 0. Because I divide by 3, right? So this is my excluded value. I'm going to put EV. So we know this. Okay? Now I can simplify. Now, a rational expression is in its simplest form when there are no common factors between the numerator and the denominator. Does the numerator and denominator have anything in common? They have an x. So that means I can simplify this. I can cancel out an x. Now when I do that, what am I left with in the numerator? I'm left with a 1. I need to have a 1 there. What am I left with in the denominator? 3. That's my answer. This is the most basic of basic problems that you can get. Okay? The excluded value basically is saying because eventually we're going to get to solving these. So solving for x. So then that means that whatever we end up getting, x cannot equal 0. If we do, it's considered an extraneous solution. Let's state the excluded value first. So we have to set the denominator equal to 0. How would I solve this? It's already factored. Okay. I could. If I distribute, I'll kind of be going backwards a little bit and then working my way forward. But if I divide by 2, it cancels out. And I have x minus 3 equals 0. So x is going to equal 3. Okay. Now to simplify this rational expression, I need to cancel out common factors. What do the top and the bottom have in common? They have a 2. Now this is where it gets a little sticky. Even though the top and the bottom both have an x in common, the fact is the bottom has an x minus 3 attached to it. Like it has a minus 3 attached to it. So you leave it. You cannot cancel out the x's when there's something being subtracted to it, or subtracted or added. We could have canceled it back in number 5 because 3 was being multiplied to x. Common factors have multiplication. But when something's being subtracted, you can't cancel out that way. So what am I left with on the top? And an x minus 3 on the bottom, and that's my answer. Now here we're dividing out monomials. We haven't gotten to like the more interesting ones. Okay? Let's look here at number 7. Excluded value first. Go ahead and do that. Find my excluded value. What's my excluded value? 0. I said 20x squared equal to 0. Divide both sides by 20. Take the square root of both sides. All the way down is 0. Okay? Now, to simplify this, look at the top. Doesn't the top have some common factors? They actually have a 5x squared in common. Both terms are divisible by 5, and both terms have an x squared. So when I factor that out, what am I left with from the first term? And then from the second? Just the 2. You found the GCF of the numerator. The bottom doesn't have any common factors because it's just one term. But when I look between the top and the bottom, what do they have in common to simplify them? They have an x squared, and 5 and 20 have a number they both can go into, right? What number can both go into 5 as well as 20? What's 5 divided by 5? What's 20 divided by 5? So what we're basically doing is we're simplifying, we're reducing that fraction. Depending on how many crossing out you have, it might be hard for me to see what your final answer is. So just write it, the final answer. We have a 1 times x plus 2, so you put 1 x plus 2. And what's left on the denominator? 4. And that's our final answer. Do you have to put the 1 on the outside? Not necessarily, because it's 1. So you could just leave it as x plus 2 over 4. Questions? Find my excluded value for number 8. Let's find excluded value for number 8. Anyone? Very good. I have to set the denominator equal to 0. I end up subtracting over 7. So x equals -7. That's my excluded value. So everything but -7 is going to make that expression defined. Now let's simplify. Do the top and the bottom have anything in common? Can I factor anything anywhere? So then this is as simple as it's going to get. That will happen. Sometimes you won't be able to simplify it down too much. But you want to make sure that you look for any common factors, and you want to look to see if anything at the top and the bottom cancel out. Dividing out binomials. Dividing out binomials. Okay. No, like these are the ones. These are the ones that are more like the types of problems that you're going to get. So I was waiting to get here. And plus, I like this unit because you do all this work, and then you get just to cancel and cross stuff out that's not in common. It feels good. It's like you're gonna get a little bit of joy and cancel. Like yes, it's in common, and you're just gonna feel so good about it. Some of y'all will. Some of you get careless. But I'm just saying. All right. Let's state our excluded values and then simplify. Remember, you always do this first. Even though it says simplify, is that the first thing it says to do? No, you always state your excluded values first. I have to set my denominator equal to 0. When I do this, what'd you say? I sure am going to have to factor. In my tiny x, what goes on the top? On the bottom? What are my numbers? 5 and 3. Okay? So x plus 5, x plus 3. I just want to give, folks a chance to figure out, what the numbers are. So I need to set both of these equal to 0. What are going to be my excluded values? So now I need to simplify this. And to be honest, you've already done half the work. When we factored the denominator to find my excluded values, we factored this problem, or the denominator of this problem. So the same factors you get when you solve for the excluded value, you can still use those to simplify this rational expression. Now all you have to do is you have to factor the top. What goes on the top? -3, 2 on the bottom. Okay. I'm looking for two numbers that multiply to give me -3, add together to give me 2. What are those? 3 and -1. 3 and -1. Do they have anything in common? What? No, not an x. The x's are attached to things. Like at the top, this x is attached to a +3. This x is attached to a -1. Do they have any common factors? Like parentheses? Say it a little louder. Someone's saying it very faintly. X plus 3. Isn't there an x plus 3 at the top and an x plus 3 at the bottom? Those are called factors. And if they're in common, they can cancel out. So if there's an x plus 3 at the top and an x plus 3 at the bottom, they can cancel out. And what are you left with on the top? What are you left with on the bottom? And this is as far as you can go. Do not sit there and try to cancel out those x's, because at the top, x is attached to a -1. At the bottom, x is attached to a +5, and you can't cancel out that way. Okay? You're looking for common factors that will cancel out. And you want a hint as well? If you figure out the bottom, you know they're going to have to cancel out. Something's going to have to cancel out. So if you ever get stuck on your numbers, look at your factors to see if they can help you out along the way. Set the denominator equal to 0. Let's factor this to solve for the excluded values. It's two terms with a minus, and both of these are called what? Perfect squares. So to factor them, we need to take the square root of x squared and the square root of 4. That's how it factors. Oh, then we got set them equal to 0. When I set them equal to 0, x equals what? And +2. These are our excluded values. And by doing the factors, I'm able to already have the bottom factored out. So even though you might have been able to add 4 and then take the square root to find the excluded values, by factoring it, it helps you out on the simplifying part. So I got to factor the top. What number goes on top of the x? On the bottom of the x? And before you say it out loud, four and -2. Those are the two numbers that multiply to give you -8, add together to give you 2. So that's x plus 4, x minus 2. X minus 2's go away. I'm telling you, it's a good feeling when they cancel out. What are you left with? And you can't go any further than that. Okay? This is how you simplify with the binomial. questions? Now realize the top and the bottom can consist of anything. They can consist of problems that have just a GCF to be factored out, difference of perfect squares to be factored out, A is greater than 1, A is equal to 1. It could be any one of those factoring ones, so that's why I went over factoring with you guys, okay? Now these, we're going to simplify still some more. Let's state our excluded values. Set the denominator equal to 0. Just like before, let's factor this in order to solve it. So you want to switch them? Yeah, you can. Something wrong with putting them in order. But now my question to you is there a GCF? I suggest factoring out that negative 4. So negative 4, anything else they have in common? X. Anytime your largest exponent is negative, so in this case the x squared was negative, I would factor out the negative. It makes it a little bit easier, especially when we get to the simplifying part. When I take out a negative 4x from a negative 4x squared, what am I left with? When I take a negative 4x out of a positive 12x, what am I left with? So now I said both of these equal to 0. And I solve. X equals what? 0, because I have to divide by a negative 4. And then x equals positive 3. These represent my excluded values. We'll take a moment before we actually get to the simplifying part. I got my bottom factored already. I took out a negative 4x, and that left me with an x minus 3. How can I factor the top? What about 3? 3 is the greatest common factor. When I take out a 3, what am I left with? And what do you see? I can cancel out my x minus 3s. So then that leaves me with a 3 on the top and a negative 4x at the bottom, which is really written as a negative 3 over 4x. Okay? Anytime the denominator or the numerator is negative, it means the entire fraction is negative. And that's our answer. How is this? It's like the underlying thing, though, is factoring. You notice. Okay. Let's do this last one. All right. Set the denominator equal to 0. No. Remember, anytime that first term is negative, you should factor out a what? No, that would be a 0x if you wanted to do that. If I factor out a negative 1 from both of these terms, that leaves me with x squared minus 16. How does that factor? How does x squared minus 16 factor? X plus 4, x minus 4 is another difference of perfect squares. Remember, you take the square root of x squared, take the square root of 16. One's a plus, one's a minus. Yes, they're actually not going to be the same thing because one's a plus. So one is going to be a what? And one's going to be a positive 4. What about here? Negative 1 equals 0. What's that? gibberish. Okay? Anytime your GCF is a number, there's not going to be an excluded value for it. If it was a variable, then that's a different story. Almost there. Almost. Last one, Jesus. Okay. Woo! Let's factor this. I already know the bottom. The bottom's going to factor down to be a negative x plus 4, x minus 4. How does the top factor? What are my two numbers that multiply to give me negative 12 that add together give me negative 1? Negative 4, positive 3. So x minus 4, x plus 3. Anything cancel? The x minus 4s. That whole factor, x minus 4, goes away. So then I'm left with an x plus 3 and an x plus 4 with the negative 1 out in front, which really and truly just makes the entire fraction negative. Well, when we're looking for the excluded values, we canceled it out here, but it's still a factor when we simplify it. And that's how you simplify rational expressions. Underlying theme, factoring. Like I rhymed there? Yes. Okay? So make sure that you always state your excluded values when? First. And then you simplify by canceling out common factors. Okay?